All right, so on your practice assignment here, this is number 2. So we're going to go over this one. So we want to prove that this is an identity, and so we want to focus on one side, and we want to manipulate it so that it looks like the other. The seemingly more complicated side would be this one, although the other thing you want to look at is there is an indicated operation, which would be this multiplication, right? So in multiplying that out, that's probably another option. You don't have too many options with this one. This is part of an identity, but there's some operations to do with this one, so that's a good one to do. Okay, so cotan. Let's change cotan first of all. What is cotan actually? That is cos theta over sine theta. Now, do we want to change that? Well, we have a tan here, so if we changed this one, then we'd have to change this one. So we have to change all three. So they're all in the form of tangent, right? Tangent, 1 over tangent, tangent. So you don't have to, in this case, you don't have to change into cos or sine. Okay, don't do that. Tan times cotan, you multiply that, what's that? That's just 1, because they're reciprocal identities, right? It'd be like 5 times 1 over 5. Well, that's just 1. Tan times cotan is 1. What's tan times tan?
Tan squared.
It's going to be plus tan squared. Now, this is a super easy one, because as soon as you do that multiplication, now you see that this is part of an identity. 1 plus tan squared. We'll go back to our identities page. Do you see that somewhere? Oh, right here. 1 plus tan squared. And that's an identity right there, equals secant squared. So we're going to just change that to secant squared theta now, and then you can see that we are done. QED. Quod erat demonstrandum. All right. Got that? Easy, right? Okay. All right, so here's number 6. And again, similar sort of question, right? Very, very similar. We look at the left side here. That's part of an identity. We could change that around to 1 minus cos squared. But this is there's an operation here. So let's do this multiplication. Let's see what happens when we do that. So I'm going to work on the right side. If we multiply this out, 1 times 1 is 1, plus cos theta minus cos theta minus cos squared theta. So it's a difference of squares here, isn't it? Because plus cos theta and minus cos theta, they cancel each other out. Now when you see this, you know that sine squared actually is equal to 1 minus cos squared as part of our Pythagorean identity. And again, it's this one rearranged, right? 1 minus cos squared equals sine squared. So we're going to just change that to sine squared, and that would be because of the identity. And so there you go. Simple as that. We are done. Easy, right? These ones are just one step, and then all of a sudden you can use an identity. Boom, done. Those ones are easy. Okay, so here's another example here. This is question number 11 on your sheet. And this one looks really scary, right? We've got lots of squareds, and 1 to the 4th over here, and secant squared, and multiplication, and addition, or subtraction. Well, what you want to do, first of all, left side is more complicated, so probably a little more to work with there. And what I see here in this first term, because even when you have products, you have two things multiplied together, that's still one single term. You've got a subtraction here, you've got another term. So you could do a number of different things. You could transform tan squared, right, into something involving secant squared. Or you could factor a tan squared out. You could factor a tan squared out. So that's the first thing that pops out to me. So I would tend to want to go here. Tan squared theta. Let's factor that out of this. Really, this is a binomial, 2 terms. So if I divide tan squared out, what am I left with in the first one? Secant squared theta. What am I left with when I divide tan squared out of this one? A 1, right? Good, minus 1. Okay, all right. So a few things that come out here are, this looks to be part of an identity, right? And so we head over to our identities sheet there, and it looks like, is it something like this right here? This one right here? So 1 plus tan squared equals secant squared. And I have secant squared minus 1, so what does that equal?
Tan squared.
That's tan squared. So here I have tan squared theta times tan squared theta. And now I can multiply those to get tan to the 4th theta. And that is what the other side equals. So I'm done. Okay? So here's some some pretty simple 1 or 2 step sort of proofs. Pretty easy, right? Okay, so for our next example here, this is number 15 on your paper, and this is really big, long, and ugly. We're starting to move up a level here, aren't we? So, boy, what jumps out at you here? From the examples that we've done before, is there anything that jumps out at you here, or do you see a pattern of some sort, or what do you guys think?
I see the foil.
You see a foil? Okay, can you tell me more about that?
If you consider cos squared
So,
theta as x,
okay,
and then
okay. So what you're saying is you see a bit of a quadratic situation here. Okay, let's just outline this. And so we have 3 terms, right? It appears that if we did cos squared times cos squared, or 2 cos squared times cos squared, we would get this term. And sine squared times sine squared, or if one was negative, we'd get this term. And then the middle term would be a collection of cos squared and sine squared. So yes, that's very good. This is a quadratic. So let me just write it to you like this. Watch this. This would be like 2x squared if x was equal to cos squared theta. That's like 2x squared. This would be like x y if y was sine squared theta. Right? And then over here it would be minus y squared. So that's a bit of a quadratic, and yeah, we can factor this. We should be able to factor this into 2 binomials. Okay? So let's see if we can do that. And I'm going to stick with the xy here, okay? Just because that might be a little bit easier. And you could certainly substitute variables in for these trig functions just like I'm doing here if that makes a little bit more sense to you. So let's say I would probably do a 2x and an x, right, to get 2x squared. That's really the only combination that we have. And then over here, we'd probably want to do y times y. 1 is a negative, though, so we have to put a negative in one of these 2 spots. Now, this is a positive middle term, so what we're going to see, okay, is we're going to have 2xy and we're going to have 1xy. So which one of these should be positive and which one should be negative? Should be a positive 2xy, so it looks like the plus sign should go there to make 2x times y be positive. So that would be plus 2xy. This one should be negative to make minus xy, and that will give us this middle term. And these 2 will multiply to give us a negative y squared. So that's pretty messy here. Let me just get rid of some of this stuff here now. But that's how we want to factor that. So now we go back and we say, all right, well, let's just resubstitute here. So this is actually 2 cos squared theta minus sine squared theta. Is that right? And this is times, what's this one? Cos squared theta plus sine squared theta. Okay? All right, so we've factored that now. Does that get us any closer to what we see over here on the other side? It does, actually. Now I see I have the same thing over here, see? But I have this to deal with, so what do I do with this? What do you notice there? That's an identity. What does cos squared plus sine squared equal? Uno, sombrero. So look at what we have, this, and you could do something like this as well in your work. Kind of that goes to 1. Sometimes there's a little arrow there. You can say that's 1, it goes to an identity. So then you have just 2 cos squared theta minus sine squared theta. And I will understand what you mean there. That equals 1, which it does. It's an identity. And so there you have your 2 parts being equal. And go QED. I am done my proof. Questions about that one?